We're going to come back to some word problems that are slightly different. They still rely on the distance of one participant and the distance of another participant is going to equal some total. So we have two trains and they're 800 miles apart. So one travels from city X and one travels from city Y. So they're going toward one another on the same track. Okay, cool. That sounds like a really bad idea. They are headed for a head-on collision. Oh me, oh my. One is going 67 miles per hour and the other is going 53 miles per hour. All right, I guess apparently Ricky's important. How long does Ricky have until they hit one another? Can he get all the passengers off in time? Really, I'm just trying to be clever here. We just want to find out how long is it going to take for those trains to meet. Now, they started 800 miles apart. Okay, so the distance that this one train goes and the distance this other train goes, he has to go some portion of the 800 miles, and this other one, she has to go another portion of the 800 miles. Are they going to go exactly the same? No, because they don't have the same rate. And again, we are assuming that they are traveling at the same amount of time. Or they're leaving at the same time. So distance of the one guy plus the distance of the other person is going to be equal to 800. So T is going to be the time the trains travel until they hit. And notice I'm doing this a little bit differently without a label box, just to show you a different approach. So distance of 1, let's say this is distance of x. So that's 67, that's rate times the time. That's this one partner's distance. Okay, I need to add y's distance. So that's going to be y's rate times some amount of time, and that's going to equal 800. So I go ahead and I add these up, and I get 120t equals 800. I divide both sides by 120, and I get 800 over 120, or 80 over 12, and I'm going to divide both by 4 at first, and I'll get 20 over 6. Now I'm going to divide both by 2. That doesn't make sense. No, 20 over 3. Okay, so I have 20 thirds. Okay, so the time, so it takes 20 thirds hours, or 6 hours, and 2/3 minutes, which is really 40 minutes. Because think about it, what's a third of an hour? That would be 20 minutes. Okay, it takes 6 hours and 40 minutes for the trains to collide. All right, now, can Ricky get all the passengers off in time? Don't worry about that question. That was just trying to be tricky, funny. I would need to give you more information about that. Now, let's look at this one. This one brings in a little bit of a different complication. Two astronauts start floating toward one another from space stations that are 405 miles apart. So here's this space station, and here's this other space station. They are 405 miles apart. So when I'm going to do the distance of the female astronaut and the distance of the male astronaut, it's going to equal 405. The rate of the female is twice the rate of the male astronaut. Okay, so female is 2 times the male. So I'm going to say the male's rate is m and the female's rate is 2m. In 3 hours, they meet up for tea. That's awesome. So I know how long they went. They went 3 hours. Notice again, I'm not putting 405 in for the distance. I'm getting distance by going 2m times 3, 6m. M times 3, 3m. So the distance the female goes is 6m. The distance the male goes is 3m. And I get 405. So 9m equals 405. So what is m again? Oh, that's the rate of the male astronaut. So 405 divided by 9 goes in 4 times. So 45 miles per hour. Now find the rate of each astronaut. So 45 miles an hour for the male. Now, how do I figure out the female? Oh, she's twice the rate, or 2 times m. So she's 90 miles per hour for the female. Now, to get full credit, I would then need to check this. So I'd want to make sure that a female going for 3 hours at 90 miles per hour, she'd cover 270 miles. A male going 45 miles per hour for 3 hours, so that would be 135. Okay, is 270 plus 135, is that equal to 405? Yeah, 405 miles. Cool, so here's my answer. And I did all the parts that I needed to get all 5